Good evening, everyone, and welcome back to the channel. Now, I'm going to take on a Sudoku here from Marty Sears, who's been producing an enormous number of puzzles lately. But I wanted firstly just to show you another puzzle. This one here looks fairly unassuming. This is an unbelievably good puzzle, and it was featured on Cracking the Cryptic a few days ago, but I discovered it the following day, and it had come so highly recommended by Cracking the Cryptic, I thought that I should try it myself. I did it today for the channel. It was just mind-bendingly good, and I discovered at the end that around the 5 or 10 minute mark, I had muted my microphone to sneeze, and when I unmuted it, I didn't click the button properly, and the rest of the recording was silent. So, and this is, without wanting to give too much away, this is not the kind of puzzle that you can just kind of do again just to kind of show someone through it, or that you'd forget and have to and be able to kind of resolve as if you were doing it for the first time. This is just one of the most memorable puzzles you will ever solve. If you're a variant Sudoku solver, give this a go. 3 out of 5 for difficulty. It is just ridiculously cool. So that's all I'll say. And we're going to come back to this puzzle here from Marty Sears. So this has an unusual rule set. I think every element of these rules is, I think, novel. I haven't seen before. So let's read the rules and then give it a go. So normal Sudoku rules apply. Well, that much is normal. So we have every row, every column, and every one of these 3x3 boxes will contain the digits 1 to 9 once each. Now, the second rule is 5s live in Dutch flats. Every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So if there was a 5 here, there would have to be a 1 above it, or a 9 below it, or both. And that is true for all the 5s in the puzzle. That rule, actually, I have seen similar. In fact, at least one of my puzzles had a similar rule where it was, I think every 1 in the puzzle needed to be adjacent to a 2 or something like that. And anyway, now we have this hot and cold lines, which is these red and blue lines. Any red line has a higher total than any blue line. So very novel idea this. So what that's saying is that the digits on this, or let's make it an easy one that we can see clearly, that's a separate line. The digits on that line must sum to more than any of the sums of the blue lines, which is quite an interesting constraint. And this has a higher total. I assume that means that the sum of the line. And as you see, nothing at all indicated in the middle of the grid, and clearly no numbers, and strikingly, not just no numbers, but no explicit mathematical clues. There's implicit mathematics going on here, but there's just nothing at all told to us in normal mathematical language. So this is going to be really interesting, and supposedly 2 out of 5 for difficulty, so maybe not as hard as it initially kind of seems. So let's consider how this is going to go. So blue is the lower of the digits, and so what strikes me is that if we take a long line like this one, we can determine, well, this could have a minimum value of 1, 2, 3, 4, 5, which would be 15, plus the cell on the end here for 6, which could be a 1. So the minimum that this can be is 16. I might actually try to use the line tool to explain, to make it clear what I'm pointing at there. So I'm pointing specifically at that line. That has a minimum total of 16. And we know from the rules that every red line must be higher than every blue line. So that means every red line is higher than 16, which is very forcing, because this yeah, it was 16. So that means that they're all 17 or more. Right, so this line here is only 2 cells, so it has to be at least 8, 9, which would be 17. It could also be 9, 9. Don't know how to quite indicate that. It could equal 18. So yeah, how do I? There's at least 1 9 in there, and there might be 2. I think I'm just going to have to remember that. This is true for this as well. Well, actually, that's going to give us, sorry, that is going to give us a few things. We have an 8, 9 in the box there and an 8, 9 here. Right, so this can't actually be 9. If this was 9, these would both not be able to be 9. They'd be 8 because the 9 sees them, and then that's only 16, and we have to be more than 16. So that actually is an 8, and that's a 9. And there's 2 digits, and the 8 here forces this to be a 9, and this 8 forces this to be a 9. So this is indeed 2 9s for 18. There we go. So we've got a start. That's now also starts to become interesting about these 5s, because every 5 in the grid must have a 1 above it or a 9 below it. Now the 5 in this box can't have an, I was going to say it can't have a 9 below it. It can if it's down here. I was going to say this can't be below the 5 up the top, above the grid, but that's probably not the place to look anyway. Let's just, let us just consider. So all of these are 16 or less, and all of these are 17 or more. We could also, well, sorry, what I should do is recognize that this is the minimum that we suggested. This has to be precisely 1 to 5. And this has to be a 1, because if it weren't, this would be at least 17, and that would not be less than this. So that's where we should be looking, at least momentarily. 1 up there. 1, 2, 3, 4, 5. Right, so this here is 5 cells. So that's a minimum of 15 and a maximum of 16. So it has to be it has to have 1, 2, 3, and 4 on it. And then either it's got a 5 for 15 or a 6 for 16. So I will indicate that like that. It's a bit over pencil marked. There's no 1s down here, but we're going to get presumably some, yeah, we've got like a whole sextuple here. Of which the 6, so we've got 1, 2, 3, 4, 5, and 6 in these 6 cells. So that means a few things. It means that these are 7, 8, and 9, but it means that in this set here, so I guess it's a quintuple of 2, 3, 4, 5, and 6. The 6 is not in here, so it is in here. So the 6 on this line must be in those particular cells. Good. Oh, I see. Right, no, I missed the whole point. So we're back here. This was a quintuple, and because it is, where's the 6 in that quintuple? It must be on here. And as soon as we know there's a 6 on there, we know that this line is 1, 2, 3, 4, and 6, because it had to be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6. So it is 1, 2, 3, 4, 6, and there's no 5 on it. The 6 is in here. We take the 6 out of these, and now we're in some sort of sanity. Now 5, 7, 8, and 9, it still holds that these can't be 7 and 8, or 7 and 9, or 8 and 9, because this would make it too big. So there must be a 7, 8, or 9 in here, and there must be a 5 on there. And again, on this line, coming back to where we ended up, there does have to be a 1. There always had to be a 1, and it had to go. It now has to go there. I could have probably actually said that right. Yeah, right when I started doing this line. Anyhow, that's interesting. The 5 in this row, 5 in the grid must have 1 directly above it. Right. Well, the 5 in this row does not have a 1 directly above it, because that 1 would mean the 5 would have to be there. So the only other alternative is that the 9 in the column is below the 5. So this is now 5. That's nice. Now, let me just consider what's going down here. 6, 7, 8, and 9. We've got a similar thing with this line here. These two digits here, they can't have a 9 because even if it was the minimum there, 9 and 6 for 15, and this was a minimum 2 because the ones are there, that's 17, which is too big. So you cannot have a 9 on there at all. For the same reason you can't have 8 and 7, because that's 15 plus 2 is 17. So you must have a 6. So we can take the 6 out of those, and we can say there's definitely a 9 in them. Oh, in fact, that 9 up there places the 9, so that was easier than I thought. We get that 6, 7, 8 triple with the 6 in there for certain. 6 and 7 or 6 and 8. This will be 2 or 3. If it was a 4, then 4 plus 6, 7 would be 17, too big. But the 6, 7, 8 triple makes this a 5, 9. And we can then confirm that's a 7, 8 pair. And we've got 2, 3, and 4 to place in the row, with that being a 4. Now, also, this 9, the 5 in this column, I couldn't have thought about this very clearly when I got the 9 because I didn't know where the 1 is. But I could have said that the 5 is definitely not going above this 9 in this column. So it must go below this 1 in this column. So this is a 5. We take the 5 out of here. And there will be a 5 in there. And that's not surprising. Same deal here. This 2 line can't have a 7 and an 8 because that would... Oh, no, sorry, that can do. That's not the same. Scrap that. Let's consider these 3 digits. There's a 5 in there, and it has to have either a 9 below it or a 1 above it. Well, it doesn't have a 1 above it because the 1's are at the bottom, so it must have a 9 below it, so that's a 5. I can see now, when I first started, I thought this is feeling quite tricky, but it is getting easier. Now let's just do Sudoku on 5s there. There's a 5 in one of those. A 5 there would have a 9 below it, that's fine. But a 5 here, that could have a 9 below it as well. So either of those I think is possible. But let's continue our journey. This is 6, 7, 8, 9. That line's fine. What about this massive long line? That's pretty... Oh, that's going to have to be minimumed, I think. If that was 6 and 7, that's 13, 14, and a 2 makes 16, and that is the maximum it can be. So 2, 7, and 6 are forced. And that's a 3, and that's a 4. 9 means that can't be an 8, because that would make 17. So 7 it is, which is the maximum. This is actually really nice. Not that I'm surprised, mind you. So that's 7, gives us an 8 over here, a 7 over there, a 9. Now, a 9 can't go with an 8 on this line because that makes 17. So this is a 6, this is an 8. It's just surprising how fluid this is actually. So the 5 is satisfied there, the 5 satisfied there. The 5 in here has to be either below a 1 or above a 9. Well, it's not above a 9, so there is a 1 in here above that 5. Now, what am I left with? All the lines over here are pretty much sorted. The 5s are dealt with. We might have to move up the top of the grid, I think. Oh no, sorry, this is 14. So this can't be a 6 or a 4 or a 3 because that would break the 16 maximum. So this is a 2. And we get a 3, 4 pair. We can make that, make that a 1, 2. 3, 4. This is a 6. And that is probably that then. What about this line here? Actually, I never considered that line. That was... yeah, I considered this one. But I could have also done this one, and there might have been some combination of them that might have helped. But anyway, 3 plus 6 is 9, plus 7 is 16, plus 5. Oh, sorry, they're not joined together. Thank goodness. I was like, that there is not joined. Good grief. So that's 12. And so this has to be a maximum of 4, so it can't have a 4 in it, and if it has a 3 then it must have a 1, so that now sums to 16, which is the maximum. Yeah, nice. That solves everything else. Oops, like so. And I think the 3 and 4 remain unsolved, but that's quite interesting the way that's all come together down the bottom. And now we can occupy ourselves with a bit of Sudoku, I think, just to... It's probably going to be useful just to help with these 5s. Or maybe not. What about the 8? So there's an 8 through there. It's maybe not that valuable. So we've just got to consider how to deal with the top. And I left the top earlier because it didn't seem that tractable, and what I've done down the bottom doesn't seem to make much difference. So let's just see what happens here. So 9 and 1. Yeah, that's still possible for the 5 to be above the 9. There's going to be 5s in here. And okay, so the 5 that, let's say this was a 5, it would be below this 1. Then the 5 in this column would be in here somewhere, and it could still be 5 with below a 1 here. Only just actually for this line, but oh no, actually that wouldn't work. So, although that's assuming that was a 5, but if this was a 5, it would go the other way. Let's say, oh well, actually let's consider this line here, because it doesn't have a 9 or a 5. It doesn't have an 8 either. So actually 6, 7 and 4 is the maximum it can be. And that must be what it is, because that sums to 17, which is the minimum these are allowed to be. Nice. Okay, so that actually does resolve the bottom. And a 3 in the corner losing its religion halfway through the solve. Now, so we've got 1, 2, 3 and 8 to place here. That's not 1 or 2. These 3 have to be more than, have to be 17 or more. So if that was a 6, well, I guess what we can say is these probably can't be 1 and 2. Oh no, well, one of them has to be, because 1 and 2 are in here. So if there was a 1 on here, the maximum the other two could be would be 8 and 7, making a total of 16, which is too small. So there's not a 1 on here, and this is a 1, which makes this a 1, which by our reasoning earlier puts the 5 below it, and now we get a 5 in here. And that 5 can't be below a 1 because the 1 in the box is already off to the side, and this can't be a 1. So this 5 must be... it must be above a 9, and that's that one. That's nice. It's kind of neat. So we determined that there is definitely a 2 on here, and that has to go with 8 and 7 to be big enough. So there's no 3. That is a 2-8 pair. That's a 7. That's a 3. And that's a 4-6 pair. This is it's a very cool idea. I don't know how Marty comes up with these things. Now, in the column here, we still need a 3 and a 4. And down here, we still need a 2 and a... What is that? Why can't I see it? 2 and a 9, okay. And then 6, 7, 8 down there. Not altogether useful. Let's just consider. So that's 6. So these two cells have to sum to at least 11. They don't have 9 and 8, so they're selected from 7, 6, 5, and 4. If you had a 3 on here, plus 6 is 9, you'd have to have an 8 to get to 17, but the 8's already taken. So this is from 4, 5, 6, and 7. That's not a 7, and that's not a 5 or a 7 because of these ones. So that's... Oh, so that's actually really limited then, because if that's 6... Oh yeah, this has to be at least 11, and then now it can only get to 11. So this is a 6-5 pair with the 6 there and the 5 there. You couldn't put a 4 because 4 and 6 is only 10, plus 6 is 16. Too small. Nice. So now that's 11. So these two, well, they only have to add up to 6 now at minimum. So that seems pretty... Well, I was going to say it's pretty achievable, but actually 5, 6, 8, and 9 are gone. So if there was no 7 on the line, this would have to be... Oh no, it still would have options. Sorry, I don't know what I'm saying. That 6 though gives us the 4 and the 6 over here. Actually, we place the 5 now, so we get rid of that 5 pencil mark. 1, 2, 3, 4, 7. That's not a 7 or a 1 by the 1, 7 here. The 4 and the 3. So that's 1, 2, 7, and then 1, 2, 3, 4, 7. So 4, 2, 7, 1, 3, just by Sudoku down the bottom. Right. So there's a 5 in one of these cells by Sudoku, and that must have either a 1 above it or a 9 below it. They both seem possible. So the 5 in this box is in here. There's a 5 in here. Oh, sorry, no, there's a 5 in there specifically. And that has to either have a 1 above it, which, that 1 there is resolved. This is a 2. There can't be a 1 above the 5, so there must be a 9 below it, and the only place for the 9 is there. So that's 9, that's 5. That gets rid of that 9. Well, you have to be a bit careful with these lines, because if we put 8 and 7 on one of them together, that would be fine. You can make a really big line, but you'd only be left with 1, 3, and 4. 1, 3, 4, and 6. So the maximum for this line would be 3, 4, 6, and 5. Oh, that's big enough, actually. That's... but... Yeah, let's just do some Sudoku before I get too muddled. That's 6 places the 6 there. So 4 and 5 is 9. So these have to add up to at least 8. And the 6, these have to add up to at least 11. Right. So 8, 7, 4. They still could be 7, 4, could they not? No, they can't be 7, 4 because of that 4, 7. So if these have to add up to 11, if they didn't have an 8 or a 7, oh, sorry, if they didn't have an 8, they would have to be 7, 4, because that's the only way you can make 11, but that doesn't work. So there is an 8 on here. And then the 7, yeah, the 7 must be over here, because otherwise you're going to have 1, 4, 5, and what would the other digit be? 3. 1, 3, 4, and 5, which is too small. So there's a 7 on this line. I think I probably could have seen that in a different way earlier. But not to worry. So 7, 12, and then the other two have to add up to at least 5. And it's only 1, 3, and 4 left. That's, well, 3 and 4 there actually means that from here we've got 3 and 4. That 4 prevents that. So actually there is a 4 on this line. And there's a 4 through there by Sudoku. All right, well, the 1 simply cannot go in this line because 1 plus 6 is 7. You'd have to have this being a 10. So this line is now forced to be 1, 4, and 7. Old snooker maximum, because we know the 7's already there. We know there's a 4 there. So this actually is 1, 4, 7. So let's just... And when this one just can't be a 1 or a 7, so there is the 4. And then we get the 1, 7. Not sure if that's resolved by Sudoku yet. I don't think so. This is the only place for the 3, and this is now the 8, which is going to give us these. Oops, sorry. That's a 1, 7. That's a 3 by Sudoku. There we go. 1, 7 pair means this is not 1, 7. It's 2 and 4. 1, 7. So 5, 11, 14. This has to be a 4 to be big enough. And the 1, 7... That's interesting. The 1, 7 is a deadly pattern. So normally speaking, you wouldn't know whether in the final solution you've got that or swapping them around like that. So what will differentiate that is the requirement that the 5 have a 1 or a 9 above or below. So I think this is going to have to be a 5 to force that to be a 1. Oh, I guess there could be one here as well. So one of those will be true. That's what we call solving by uniqueness, but I won't worry too much about that. So this is 3, 4, 8 by Sudoku. We need a 4 and a 6. No, not 4. 6 and a 1, is it? 1 and 6. Just checking, nothing else to know there. I don't know what I'm doing here. There's no 4 in here either. This is 1, 4, 7, 2, 9, 6, 3, 8, and 5. Oh, so the 5, yeah, the 5 is over here, but we don't really know. So, so then we've got 2, 4, and 7. And I trust that now, I think. I'm just going to check that I haven't missed any lines here. I don't think I have, so it's presumably Sudoku. I wonder, actually, in theory, this puzzle could require you to use uniqueness, but normally that's not the way puzzles are designed. Yeah. Yeah, I might just kind of power on with the others with normal Sudoku. 1, 2, 3, 4, 6, 7. Oh, that's apparently the only place for a 9, is it? That 9 gives us 2, 9. Oh no, sorry, I didn't see this pencil mark. So actually this is the only place for the 9. And the 2 takes the 2 out of there and there. So in this column, the 5 here, it can either go below the 1 or above the 9. So that's kind of happy. 1 and 5, so that's not a 1, that is a 6, that's a 1. 6 takes 6 out of there. 2, 8, 4, 6, 7. This is a 3 and a 5. Marrying up with the 3's over here, so the 3 in this row can't be in here, can't be in here, must be in here, and it is there. So just a matter of passing these final little Sudoku deductions. 1, 2, 5, 8. Also, just to consider these 5's. I think the only 5's though that we don't have are these. Oh, right, okay. The 5 in here has to be below a 1 or above a 9, and it's not above a 9 because the 9's down here, so it is below the 1 here. So that will resolve the deadly pattern up here, and put the 5 there, which is above a 9, so that is satisfied. Now by Sudoku we can go around resolving some stuff. That's not a 7 or a 4, that's a 6. That's an 8. That's a 1. What have we got? 7, 6. 4, 7, 2, 8. So 7 gives us 4, 7, 4, 2, 8, 8, 2. There we go, solution is correct. Very nice. Beautiful. Well, I stumbled a little bit at the beginning, but after that, pretty smooth stuff. And a very cool idea, as we have come to expect from Marty. So thanks, Marty, for that, as always. I am yet to post Marty's Rat Run 10 puzzle, which was another beautiful one in the series. The reason for that is I've had trouble editing the video because it was unusually large. I'm not quite sure why. And my software is struggling with it. So hopefully I can get that sorted at some point. But in the meantime, thanks for joining me, and I'll be back with you soon for another puzzle.